All right, in this video, we're going to look at how to integrate some parametric equations using the TI-84. Let's jump right into it. So let's say I have some parametric, some equation in parametric that I want to find the definite integral of. Let's say I want to integrate from 0 to 4, 5t squared minus 3t plus 1 with respect to t. Now, there's a couple of ways to do this, and I will show you both of those. The first way is just to say, well, this would have worked the same way as if I had any other variable. So instead of t, if I would have had the variable u, I would have ended up with the exact same numerical answer. So doing this or this works, and I can just utilize the x character if I would like. In other words, the x variable on my calculator. So if I want to just utilize the normal function mode, what I can do is turn to my calculator. I'm in function mode right now. I won't go through that right. But if I hit math and integrate, I'm going to integrate from 0 to 4, 5 times x squared, and I just hit my variable key x there, minus 3x, minus 3x, and then plus 1, and integrate that with respect to x. Again, every time I'm hitting x, I'm hitting the variable key x, which is right here on the calculator. So there you go. I get 86 2/3. Now, that's option number one, is just to use the variable x here and stay in function mode. The other option is that we can change our mode into parametric. So I go to mode, I hit parametric, and then go back to the home screen. Now I'm going to do the exact same thing. I'm going to hit math. Down here at number 9, that's function integrate, 0 to 4. Now every time I hit the variable key, since I'm in the parametric mode, that variable key will give me a capital T because I'm in parametric mode. So I just type it in as I would see it in parametric mode and then hit enter. And that's what I end up with. Again, 86 and essentially 2/3. Okay. So whichever one you want to do is perfectly fine. You can also utilize the letter T if you want, but I tend not to do that. I think that's harder to deal with than just hitting a variable key. But if you want to do that, you can. You just have to hit alpha and then the number 4 every time you hit the letter T. When I do that, again, I'm hitting alpha and then the letter T each time. You get the exact same thing. Okay. So that's quite frankly harder than just hitting this variable key. So you might as well hit the variable key in this case. So that's the whole thing. That's how to integrate a parametric function with respect to t. I'm going to do two examples of where this came up in our parametric with calculus lecture. This was an example we saw finding the arc length of this parametric curve, which happened to be a parabola pointed right on the interval from -2 to 2. So I will do that with my calculator. Now, if you don't know how to set up arc length, then you can watch that video. I'm not going to set it up and go through that again because this video is only on the calculator use. So the arc length was calculated by taking an integration from -2 to 2 of 2t, which is the derivative of x squared, plus 1/2 squared. Again, that 1/2 is the derivative of y. So that's the integration that gives me my arc length, all under a square root, integrated from -2 to 2. So that's the integration that gives me arc length. What I would do is make sure I'm in parametric mode and then go into math, number 9, integrate from -2 to 2, and then it's the square root in parentheses 2t quantity squared plus in parentheses 1/2 or 0.5 quantity squared integrated with respect to t. Okay, again, square root button is right over here. So that's the integration that we're looking at, and clearly we get 8.41 roughly. So the length of that parabola, the arc length of the parabola from t going from -2 to 2 is about 8.41. So that's it. Make sure you're in parametric mode and then just type in as you would any other integration. Here's one other example that we saw in the lecture, finding the arc length of the curve on the given interval. In this case, this was an ellipse, x equals 5 cosine t minus 1, y equals 2 sine t plus 3 on the interval from 0 to 2 pi. So we'd set up our arc length, which again, I'm not going to go in detail, but I will show you what it is. We set this up, it was an integration from 0 to 2 pi square root of -5 times sine of t quantity squared plus 2 cosine t quantity squared. Make sure the -5 and the 2 are inside the parentheses when we do that. And when we type that into the calculator, we have to be careful of that as well. So I'm already in parametric mode already. So now I just go to math, number 9, my function integrate, 0 up to 2 pi. Remember, pi is second and then the caret key. Then square root is second and the x squared key. In parentheses, -5 times sine of t. Square that. Plus, in parentheses, 2 times the cosine of t. Make sure you have parentheses around the entirety of 2 times cosine of t and square that. All of it should be underneath the square root and then integrate with respect to t. So that's what it should look like when we type that in. As always, be careful that you type in everything correctly. I'll hit enter, and I got about 23.01. So about 23.01 is my answer. So that's how we can integrate in parametric mode. As always, if you wanted to, you could have stayed in the function mode and just utilized the variable x instead of the variable t. We showed that at the beginning, but a lot of times when I integrate in parametrics, I like to use the parametric mode and then math number 9, function integrate. So that's it for this video.